Today we are basically introduction to the Python language and the computer science in general. So the Guido van Rossum, he has developed the Python language whenever he's doing his BTech. So he has done a great lot of this thing because Python is totally different from other languages. It is more like a English language. There is no such semicolons at the end of the statement, so it is very easier to read, and the space is used like in a poetry. Whenever you write, what is the difference between prose and poetry? Poetry, you see a always a separate lines, and it keeps you remember and all these things. So here also the uses Van Rossum uses space as a end of syntax, as a mark of syntax. Say most of the language like C, Pascal, semicolon used. Here he has used only the space. That is a great thing. The program is becoming more readable, and that is the best thing because programmers is pretty costly, and generally one program is written and it is redeveloped and redeveloped by maybe tons of programmers or maybe so lots of programmers. So the program should be readable, and that is the highest resources. And the program where it is run, that is the CPU, that is damn cheap. Right now in your mobile phone we have a octa-core chips like this. So the program should be readable. That's it. Yeah. Now it comes to the main thing is algorithm. The What is the difference between algorithm and program? Uh, and what is if there is no algorithm at all? Yes, that is also possible. In the whole computer science is revolving around the algorithm. Algorithm is how to tackle the problem and what is the steps, how to follow the steps to tackle the problem. It doesn't mean that every process has kind of algorithm. Maybe in day-to-day cases, we generally do it by brute force technique. We generally try every other possible. That is in strictest sense, it is not algorithm. Algorithm say if you want to find the maximum of a number, say amongst the 100 numbers, the some algorithm you follow, and if you follow to 1 million number, the same algorithm will work, and you don't have to test again for another 1 million programs. So that is the great thing of algorithm. It can be tested with small number set, and it can be definitely okay for the higher number of sets. So that you don't have to do it again the different algorithm for different input range. That is the best thing of algorithm. It should have input, it should have some number of finite step, and it should end. Now, what is the difference between the algorithm and program? Programs means you have to work in a, you have to code these things in a some programming languages like C, Java, or Python. You have to obey the syntax, particular syntax of their particular languages. Say Java, C, they require the semicolon, and the Python doesn't require semicolon. Some syntax rules, and which under ways it will work. That is the program. Then another thing, what is the program and what is the difference between process? Process is whenever it is working inside the CPU, then it is not a program, it is a process. And the process can be multi-threaded or multitasking, both can be done. That is the thing. So algorithm is the basic things of write a program. So same algorithm you can write a program in different languages, maybe in C, maybe Java, maybe Python, and you can run it on a mobile machine, your mobile computer, or your laptop, or your desktop, or your mainframe. These things. The main idea of is your complexities. When that means the how long it will take. It hardly much differ with a smaller computer and bigger computer. Maybe a bit faster, but algorithm is a core thing. So what is algorithm? Algorithm is independent of language. So whether you are using C, Java, or Python, because most of the languages have all the tools for doing such writing the program, then you can say which is the best language. We'll come to that. But the thing is that algorithm is totally different from the program. Program has first you have to select an algorithm, then you have to write a program. So algorithm you can whenever you are making an analysis of algorithm, how much time it will take. It arbitrarily it might find that it should depend on the computer. No, algorithm determines the time. Actual time maybe differs on the say if you have a higher CPU machine of then it will be faster. But the basic timing should come from the algorithm itself. The algorithm, the number of steps, and there is no such. There is some first basic type of algorithm is brute force algorithm, like a selection sort. So we have some numbers there. Then you have to find you have to sort it. Then you have to go there and find the minimum, put it at the first. Then say 100 elements, there are 99 there. Then again you go for find the minimum, go to the second, again go. This is called brute force technique. There it will always work, and the complexities of this O(n) square, and there's lots of, this is the stupidest algorithm one of them. There are lots of better algorithms there. Insertion sort is better, merge sort, divide and conquer, that is much better, because uh, uh, this thing this algorithm takes the selection sort. It takes O(n) square time. Even if it is a sorted, even it will take O(n) square time. So very stupid at all. But insertion sort is not that. It will take O(n). Okay. So even it's a sorted algorithm, if it is 100 sort numbers you give into selection sort, it will again take O(n) square time. So that's really stupid. So if it's giving to the selections another sort, that is insertion sort, I'll come to that. Insertion sort doesn't that way. So these are the different techniques of algorithm, and that is the thing. As a computer scientist, we must know. We have to know various types of algorithms, and what are the complexities. Complexities means how it behaves, the algorithm behaves with the size of the data. Maybe when the size of data is 100 is okay, but when the size of data is 1000 or 10,000, it doesn't work. So that's the thing. So that is the base thing of the algorithm. This algorithm, a computer online, is step by step that I have already told. The algorithm must end. That is one thing. Algorithm must end, and a program might not end. Like operating system we are working in a computer, that is program, it is running continuously. That you cannot say is an algorithm. Yes, it can use the algorithm in various jobs, but that is basically a program. Program may continue or may end. But algorithm should not have a loop. It is always ends. Algorithm is written in a kind of a pseudo language, like English like language. So it can, then you can make it to a programming languages. Python, why I am selecting the Python? The Python is very easy to learn, and also lot of basic data types, like we are using in mathematics, we are using set, we are using list, we are using tuple. Tuple means a immutable list. You cannot change that list. A set, you know, the unorganized elements, but only one of it will be there. It is mutable. Mutable means it's changeable. But whenever it's a frozen set, the number of items is fixed. You cannot change it. So these are the different data structures which are very useful, like a dictionary. Whenever we say in our childhood, whenever we have an English language dictionary or any other dictionary, so you have a left hand side have an index and right hand side is a meaning. The Python does support a dictionary, so the left hand side is immutable things which cannot be changed. Right hand side the description which can be changeable or which may not be changeable. A dictionary sort of things. So dictionary may contains dictionary. So all these tools which are required for solving a problem, it is built into the Python. So the data structure is very rich. So your program complexity will be, the number of lines in the programs will be less, because you have a built-in data structure. Like C doesn't have like set, C doesn't have tuple, Java doesn't have. Okay, so these are the basic availabilities. And if you import some of the libraries like NumPy library, a huge matrix calculation library, basically you know all the computations by the matrix manipulation. So this NumPy, this gives you lots of advantages of matrix. Yeah. Algorithm as program, I have already told you. Algorithm program is the implementation of algorithm to run the specific computer and operating system. Algorithm is more abstract because it is written in a English-like language, or sometimes we use a separate language called pseudo language. Is almost like easy to learn. Uh, Good algorithm is the basic class of the thing, and it is independent. I again told you, it is independent of any language whether you are implementing. Maybe whenever implementing in a Python, you get greater advantage, but you know Python is maybe uh, 10 times slower than C, but it is required. Sometimes you use Python because it is quicker to develop the program. C is faster. Maybe Python is not 10, maybe 20 times slower than C. So great thing is algorithm uses abstract, and you can check the algorithm by your pen and pencil. You may need or may not need computer. You can check the algorithm, then you can code it to a different on a different operating system, different languages. Yeah, another thing is how we measure the algorithm is good or bad. There are definitely two methods. One is time, the most crucial, how long is time. Sometimes space. You need not have much space into it. It's like that we have sent a vehicle into the Mars, and very difficult. We have right now fitted with say 120 GB RAM, maybe more, but it is not possible to enhance the RAM there, go there and put a RAM slot there. So certain limitations are there. Like we have a pacemaker, we had heart. It is not possible to change the RAM on it. Same is a mobile computer. Uh, like a laptop, you can change it, we can enhance it, but mobile computer is difficult to change the main memory, which is required. So space complexity is a factor, but time complexity is more pronounced. Time complexity, one complexity is like O1, like if a stack of items is there, you push something into it, pop something into it. So everything occurs into the stack, independent of the stack size. Stack may be near empty, stack may be full. Your operation is push here or pop here. So complexity is always O1. So if the stack is empty, left hand side, if you see the left stack is empty, then also stack is empty, almost empty. Then also you require O1 time push and pop, and it is a full O1 time. So stack is very useful. We will see the a lot of problem can be solved through a stack. So complexity is O1. Then is if you have a list, if you want to see which is the maximum of a number, so you have to read it all n elements and put it as a maximum. Then it will be, you have to traverse every element. So complexity is O(n). Like I told selection sort, there's 100 numbers, you have to sort it from lowest to highest. Then you have to go find from left, it's unsorted. Then you have to go to find and find the minimum, put it at the first. Then another 99 elements are there. Then you again find the minimum, put it at the second. Like this is a selection. So this is I have told you one of the stupidest algorithm, because it will take unsorted elements O(n) square, even if it is sorted, fully sorted. If you give into selection sort to sort it, again it will take the O(n) square. So this is a typical O(n) square algorithm. That means number of elements 100 square, the type of 100 elements is there. So certain proportional time will be the 100 square. There's another algorithm between O(n) and O(n) square, that is merge sort. Merge sort is if you have 100 elements, you divide it by half, say 50. Or it is better if you have 128 elements, you divide it by half, 64, 64, divided by half, 32, 32, divided by 16, divided by 8 and 4. Then you, when it will come to two elements, you sort it and then you merge it. So divide and merge. Then you will find it will go n log n. But in actual merge sort, we see that whenever the number of elements come to 32 in a particular sub-array, we will stop the merge sort. Before you have a say even 1 petabyte, 1 terabyte of data, the merge sort divide and conquer, divide and conquer. Then when the size come to like 32, then it will go to the insertion sort. Insertion sort is much better than selection sort. We'll come to this various sorting algorithm. It's very essential because searching and sorting is everywhere. Even the Google main thing is 99% of activities are with searching and sorting, and they put it in a different pages. So if you have a fraction of improvement, it's a great improvement. Okay, well, when I'm coming to this, the complexities, the time complexity, what I have covered, O1 complexity, like you push something into the stack or putting something into the end of the array, or putting something from the array is indexed, you take out something. It is O1 complexities. Best example is the stack. ON is finding a maximum element into the array. List is a ON. Selection sort is ON square. Anything you want to sorting. ON log n is better than selection sort, merge sort, divide and conquer. That is one of the great things. Then ON cube algorithms are there, like matrix multiplication. Typically, ON cube, if you do not do much optimization. Another algorithm, interesting algorithm is this algorithm is computable. It is called is a computable. Another is almost uncomputable. It is called exponential function, like a Tower of Hanoi. You have a three sticks. If you have a three sticks, say I have a three sticks there. I have a three sticks there. I have a let me visible. The three sticks. I have a from larger disks to smaller disks to smallest disks. There are three disks. Then if I have to transfer these disks to another disk in the same way, and we need another buffer stick. So the restriction is we cannot put a larger disk onto a smaller disk. So we have to take all the smaller disks. Smaller disks can be on a larger disk. Larger disks cannot be on smaller disks, and you can take only one. You can take only one disk at a time. So if you have a 3 disks, you need at least 2 to the power 3 minus 1. 7 transfer. If you have a 4 disks in one here, if you have a 2 to the power 4 minus 1. If you have a 5 disks, 2 to the power 5 minus 1 transfer of this. So here you see the number of operations required is not proportional to n or n log n or n square or n cube. That is very easy. It is come to the 2 to the power n. 2 is the smallest number after 1 is the integer number. But again, whenever the number of exponential go to the n, 2 to the power n, that is a totally exponential problem. It's a more difficult problem, and it is shown that it cannot optimize it. You cannot break it and put straight into the this thing. That is not done. Then it will be one problem. But if you have to follow the rules, that is, you have to take one element at a time, put it in a backup, then take the middle here, then again put the small here, then take the bigger one here. This is a typical Tower of Hanoi problem, which is the 2 to the power n minus 1 problem. It is generally called exponential problem. Thank you. Then algorithm and problem I have already told. That is another definition of an algorithm. That is Euclidean algorithm. That is how to create your GCD, greatest common divisor. Say if you have two numbers, when the remainder comes, then you try with the remainder, whatever it will come, it will be the GCD. See if you have a two number 106 by 16, and the remainder is 10. Now you take remainder this one as a you divide it by this. This way, this is Euclidean algorithm. This is Taylor used. This is algorithm. Yeah, I have told you algorithm should have input, algorithm should have output, definiteness must be there, finiteness must be there, effectiveness there. So this is whole the thing is whole coming 3 years you have to know various types of algorithms. One is brute force like selection sort, one is divide and conquer like merge sort, another is called the dynamic programming. Again that is a divide and conquer, but we have a much smarter way to this. Then there's the greedy algorithm. That means whatever I found it, that is we try to do it, that is which is the best possible time, but ultimately it may not be the best. So greedy algorithm is there. There are lots of different types of algorithms. Even like now we have a various virus attacks and mutation of virus. This is also types of algorithms are there. Genetic algorithm, like we have a lot of mutations of the COVID-19 is coming. We can have some algorithm which also can be which is also mutated. Mutation is going on, and that's great. Yeah, that is the basics of algorithm. I have already told this is the. I have covered recursive algorithm. I have not covered recursive algorithm. I'll cover divide and conquer. I have already covered. This is a kind of recursive also. Dynamic programming. I have not covered TT8 greedy, I have not covered in brute force, I have covered in selection sort, backtracking I have not covered. That will be covered later on. We'll come to know. So these are the complexities like O1, like typical operation of push and pop. O login, it is kind of a binary search algorithm. If your numbers are in a binary search tree, you can find it out by O login. Uh, this is ON, linear. It is easier, like finding a ON is one of the simpler, linear. It is simplest because it can be much linear. Okay. It can be O root n. We can try to find out. N log n I have already covered. It is merge sort. O quadratic, this is typical like selection sort. ONQ I got matrix multiplication. O2 to the power n exponential. This is I have covered it. Tower of Hanoi. And O factorial n, one of the very difficult algorithm, like it's called the traveling salesman problem. I'll cover this. Say we have a 3 places like maybe heart of the town, our college, and then in one place is our friends are staying, your students are staying, your friends are staying, somebody near Koikhali at the college, somebody say all around West Bengal or Bihar, and there may be 10 friend places. One may be at Koikhali, one friend may be at Satragachi, one may be at Patna. There's different places, and we have individual distances between this. And if salesman travel from one point, cover all the 10 friend places, and what is the minimum? Every place is connected with everyone, and how to get the minimum amount of minimum traversing time, or minimum mile, or minimum kilometer. That is a factorial problem. This is called traveling salesman problem. One thing that that particular salesman can travel a city only one time at it, only one time. He cannot make it in a loop, and it has to cover all the 10 points or all the 50 points. That is a traveling salesman. It was a difficult problem, challenging problem. This is the factorial problem. This has covered the Tower of Hanoi problem. This is, it will take 2 to the power n minus 1. Here, basically, this algorithm is the main thing of the crux of the thing, and you can put it in different languages, and almost all the modern languages have all the facilities, but some language may be easier to put it on your Android, so then you have to go for Java or Kotlin. Some language maybe at you can put it everything at the web and all this. Maybe Python is better. Some language maybe you have to run it on the same machine. Everything is one. Then C is okay. So all the languages facilities. So, but whether you want to deploy it on different machines and all these things, you need a layers of architectures are there. So, but the crux of the thing is algorithm, and this is one good thing is algorithm. You may not need a computer to test it. Maybe in difficult algorithm you might, but you can pen and paper is enough. Yeah, these are the I have divide and conquer dynamic algorithm. I have not covered divide and conquer merge sort. Backtrack I have not covered. I'll cover it in some opportunistic time. Brute force sorting algorithm like selection sort I have covered. This is divide and conquer. Whenever a huge set is there, you divide it first. Then you divide it again. Then you divide it again. So whenever you are dividing, you are getting this log n. Remember this log n, the base is 2 is here, not 10 or e. Here in the all computer science, all log base is generally 2. So that is the advantage of divide and conquer problem. The Python, one of the great thing is everything is available there. Python GUI, graphics user interface, one library is there. You can make a web-based framework. The Django is there, so your application will work on the web. You can write a game. You can write. You can visualize. You can highly computation intensive. This is everything can be done on Python. That's a great thing. The person he has developed this, Van Rossum. Python is very beautiful, is better than ugly. In my earlier videos I have already covered. So that's it. Thank you for viewing.